Alright, this is project A2 for class FSE 355. This is a presentation portion. My name is Jamie Barnes, and first of all I chose PowerPoint with narration because it's really the simplest. I goofed around with a couple other programs, but they weren't complying with me today, so we're going to try this out. The project description in this portion of the project we're needed to determine data points from the internal video of the burn room. What is the flame height at 10 different times roughly distributed throughout the video? What is an assumed pool fire diameter? What is the heat release rate at each time, and at what time is the onset of flashover? So this next slide just shows a few sample calculations that I did throughout the video, explaining how I did everything. Really, I just took screenshots, and I'll show you the screenshots here in a second. Use the simple object measured versus when we have a known height. I made some assumptions there, and then calculated the flame height. And then from flame height, calculated the heat release rate using the Hexted formula. So I included some screenshots of the fire I took, or some screenshots of the video of the fire. I only included about half of them from what's in my report, but you still get the idea. And these are the screenshots that I took the flame height from. The graph on the bottom of the slide shows the time durations that I chose, the time intervals I chose for these screenshots, the flame height, and then the measured and calculated pool fire diameter. And again, those together, you're able to plug into the Hexted formula to get your heat release rate. The asterisks in this graph represent poor camera angle, or something is going on there where I had to make an assumption. I wasn't able to exactly measure. So all the numbers, the heat release rate numbers still correspond and are pretty good there. So two figures here. I've got one flame height and then the other heat release rate. They're pretty straightforward, just one line graph each here. Analysis of the results. Honestly, I'm just going to read this to you because I wrote it and I think it's pretty good. So the pool fire diameter and flame height seem to have a direct correlation. The heat release rate is also directly related to the fire diameter and flame height. Based on the exponential growth in the heat release rate, flashover starts around 165 seconds into the video. Data gathered using audio and visual equipment can be beneficial if it is of good quality. In this video, flame height was difficult to measure due to poor camera angle. As the fire grows, the flame will be embedded by the ceiling and will have a change in direction. Flame height based on measured flame height and measured pool diameter of a non-liquid substance is far from accurate. So this concludes A2. The flashover was relatively difficult to assume in this portion of the project. There just wasn't enough information to go on, and then there are a few too many assumptions for these hand calculations to be extremely accurate. In comparison to later parts of the project, the hand calculations are off by quite a bit. Alright, thank you for listening and watching my presentation of A2.